Hey everyone, today I'll be doing the sections 1.1 to 1.5 mechanics quiz. So start with question 1. Okay, you have the square and they want you to find vector mn. Now I already explained this in the CA quiz, but I'll re-explain it again. Okay, so how I like to think of vectors is essentially, let's take this example, vector mn. Okay, you're at point m, okay, and you want to get to point n. So you'd normally take this road, right? But this road is closed. It's locked. So you're gonna have to take the long way. You're gonna have to go from M to D and then from D to N. Okay? And that will be equal to Mn. But it's just the longer way, right? So now we have that vector AB. Okay, AB, this is important, the direction. A to B is A. Okay? And since in a square you know that the sides are parallel, A to B, that means D to C is also gonna be A, right? D to C is gonna be A. Okay, however, we're not concerned with the direction of D to C. We're concerned with the direction, not the magnitude, the direction of C to D, right? Because we're going from M to D. So we're going in this way, not in this arrow, not the one that's like this. We're going the one that's like this. So that means that we're going to go in the direction of vector C to D. C to D is just going to be the opposite direction of A, right? So it's going to be negative A. Now, again, M is the midpoint, okay? So M is halfway. We're only going to go from M to D. That means we're only going to cross half of CD, right? So we're going to write half of negative A, which is negative half of A. So negative half of A. Okay, this is our first part. Now, second part here, D to N. It's given to us that A to D, okay, A to D is vector B. However, we're going in the direction of D to A. So it's going to be negative B, right? We're going like this. And this is going to be negative B. Okay, but again, N is another midpoint. So we're only going to go halfway from D to N. So we're going half of negative B, which is negative half of B. So overall, Mn is equal to Md plus Dn. And this is equal to Mn, which is negative half of A minus half of B. And this is my final answer. Okay. Question 2. Which of the following are vector quantities? I'm sure you all already know this, but just as a recap, vector quantities are quantities with a magnitude and a direction. Okay, so time and mass. Time, you can't say 5 seconds east. It's not a thing. Mass, you can't say 7 kilograms south. It's not a thing. However, please don't confuse this with weight. A lot of students do. This is not weight. Weight is a vector as weight is a force. So now we go on to the vector quantities. The velocity, yes, because I can't say 5 meters per second east. That is how you express velocity. Displacement, yes, you should know from grade 9 physics that displacement is a vector and so is a force. Because again, if I draw a force diagram, for example, I can obviously always say 8 newtons directed north. But even then, when I draw it in a force diagram like this, look, let's say like this, this is going to be 15 newtons to the right. So I'm even indicating its direction by the arrow. Okay, moving on to question 3. A, B, C, D, E is a pentagon with vectors P, Q, or S are represented in magnitude and direction by A, B, B, C, E, D, and A, E respectively. Expression. Okay, so I just have to find the vector from given these expressions. Expression, negative P plus R. So here I have P going this direction, right? But negative P will be going in the opposite direction. So P is A to B, right? This is P. So negative P will be from B to A. So this is negative P, right? I'll rewrite it. So negative P. Okay, and then plus R like this. R is the same. So it's going to be BE. Okay. Negative P minus Q plus R plus S. So negative P minus Q plus R plus S. Okay, so you might notice that if you were to follow the same method, you'd start off with negative P, which is BA. Okay, and then negative Q is this. Then R, then S. So from the diagram, you can see that it's going to be CD, right? Because I started off at C, I'm ending at D. So it's going to be CD. But if you were to do this in terms of the mathematical expression, right? You see that negative P comes before negative Q. How? Negative p is after negative q in our drawing. This is negative q here, this is negative p here. So what you can do is actually rearrange it. So it's going to be negative, if you think about it, this is minus p plus minus q plus r plus s. And you know addition is commutative, so you can swap these two. So it's going to be minus q plus minus p plus r plus s, which means it's straight away minus q minus p plus r plus s. So now we can take it much easier. So minus q going like this, minus p going like this, r is going like this, then s is going like this. And I started off at c, ended at d, my vector is cd. Okay, moving on. Negative r plus p plus q. So negative r plus p plus q. So negative r will be going like this in this direction. Then p, then q. You can see I started off at e, I ended at c. ec is my vector. Okay, r plus s. R plus s is very simple. I start off at a, r here, and then s. Started off at a, ended off at d. My vector is ad. Moving on to question 4. Given a is this coordinate, b is this coordinate, ac is 3i plus 4j, and v is 3ac minus 2ba. Okay, so they want us to find the coordinates of vector v. However, we don't have ba, right? So how would we find ba? Ba is gonna be this, right? Vector ba is just gonna be b minus a. Right? Because remember, the formula for the vector is v equals to the terminal point minus the initial point. So b is our terminal point, and a terminal means the last point. Initial is obviously initial. So ba, or sorry, it's going to be a minus b. Okay, so ba is going to equal to the initial point, which is a, so negative 3, 4, minus b, which is 5 and 0. So this is gonna be minus 3 minus 5. Where did I go? Oh my god, not this again. Okay, so I was ba is equal to a minus b, which is negative 3, 4 minus 5, 0. So minus 3 minus 5 is negative 8. 4 minus 0 is gonna be 4. This is vector ba. Now v is 3ac minus 2ba. So v is going to equal to 3ac, which is 3 into 3, 4, minus 2 into negative 8 and 4. Okay, so now I simplify this. It's going to be 9. 3 times 4 is 12. Minus 2 times negative 8 is negative 16. 2 times 4 is going to be 8. Okay, now 9 minus minus 16, the minus and minus will make a positive. 9 plus 16 is 25, sorry. And then 12 minus 8 is gonna be 4. So my vector v is equal to 25 and 4, because they want it written in the Cartesian notation. So it's gonna be 25i plus 4j. By the way, whenever you see this little house thing, it means that it's a unit vector, because remember I and j are unit vectors. So 25 and 4, this is coordinates of v. Now, if the tail of v is located at this and its head is, where do you want to find it? Okay, so in a vector, this is how you draw a vector on a graph, right? You draw an arrow. Now the arrow is composed of 2 parts. This is called the tail, and this is called the head. Okay, so this is the initial point, and this is the terminal point, right? So you know how we wrote that the vector is terminal minus initial? You can write that the vector, the vector is equal to the head minus the tail. Okay, so they want us to find the head, right? So we can rearrange this equation to say that the head is equal to the vector plus the tail. Now that we know this, okay, I just took the tail to the other side, by the way. So the head is going to equal to, what's the vector v? 25 and 4, plus the tail, which is at negative 1 and 2. Okay, 25 plus negative 1, so 25 minus 1 is 24. 4 plus 2 is 6. So my head is going to equal to the coordinates of 24, 6. And this is my answer. Okay. Question 5. Two forces acting on a particle are given by F1, I minus 2j, and F2, 2i plus 6j. The resultant is we're gonna combine our i's, okay, and our j's. So, f of, let's say f of I is gonna equal to I plus 2i, right? I plus 2i is 3i. Now, f of j, okay, it's gonna be negative 2 plus 6. So this is gonna be 4j. So now I forgot to draw these things. So now it's gonna equal to f. The resultant is 3i plus 4j. Done. Okay, now the magnitude. The magnitude is very easy. The magnitude of a vector is denoted like this. Sometimes it's denoted like this. But I'll denote it like this for simplification purposes. It's gonna be radical of x squared plus y squared. Or let's say they told you it's in the form of ai plus bj. Okay, the magnitude of the vector v is gonna equal to the radical of a squared plus b squared. Okay, so now that we know this, why is it not erasing? There we go. Okay, vector, the magnitude is gonna equal to radical 3i, so it's given in the form ai plus bj, right? So 3 squared plus 4 squared. This equals to radical 3 squared is 9, 4 squared is 16. This is going to equal radical 25, which you all know is 5 newtons. That's my answer. Okay, question 6. The initial velocity of a bullet is given by v equals 9i plus 3j meter per second. The unit vector, okay, the unit vector, there's a special way to calculate it. So the unit vector of v, which means we're going to draw the v and the little house thing on the top. Just to denote that it's a unit vector, let's sort properly with proper notation. This is going to equal to, so let's say it was given as ai plus bj, okay? We're gonna say it's a over the magnitude of v I plus b over the magnitude of v j. Okay, the formula looks a little bit annoying, but I promise once you see me applying it, it's not gonna be that hard. First of all, let's find the magnitude. Okay, the magnitude of this is gonna be radical 9 squared plus 3 squared, which equals to radical 9 squared plus 3 squared, 3 radical 10. Okay, so now v unit vector is gonna be, so we're gonna take the coefficient of I first, 9 over the magnitude 3 radical 10 I. Okay, this is gonna simplify to, let's go say this is vi, let's approach this step by step. So the 3 here cancels 3, so 3 over radical 10. For the I, it's gonna be 0.95 I. Okay, now for j, let's erase the magnitude because I don't need it anymore, I already know it. It's gonna be 3 over 3 radical 10. That's equal to 3. Okay, now remember, I'm just applying this. So this part goes with here and all of this goes for this, right? But I'm applying it step by step instead of, one step at a time. So 3 and 3 will cancel. It's going to be 1 over radical 10. 1 over radical 10 on a calculator gives you 0.32 J. So my final answer is 0.95 I plus 0.32 J. Done. Next question. What polar coordinate pair corresponds to the position vector -4 and -3? Okay, this isn't too bad. So, I'm gonna use the manual way, which I said 2 weeks ago, I believe, in the mechanics AMS quiz. I said I'd teach in the course practice video when the periodic comes, because it might come in a written part and you never know, you might need to show your work about this. So, for this, okay, when you want to change from Cartesian notation or Cartesian XY plane, whatever it is, to polar, okay, manually, not on a calculator. I will start using the calculator method after question 21, because question 21 tests you on this part here, tests you on the formulas you need for this here. So if x is greater than 0, then it's very easily the theta, okay, theta is gonna be, this is only for finding theta, just as a quick refresher, polar coordinates are expressed as r comma theta. R is the magnitude, so you don't need it, you know how to solve the magnitude. Magnitude, let's call it r, is radical x squared plus y squared. This you should know. Theta is a bit different, so this is theta is the angle, okay, it's the angle between the vector and the positive x-axis. Okay, this is important. So if x is greater than 0, then it's gonna be the inverse tangent of y over x. Okay, if x is less than 0, so x is negative, theta is gonna equal to 180 degrees plus the inverse tangent of y over x. Now, what about if x is equal to 0? If x equals to 0, there's two more cases. If x equals to 0 and y is greater than 0, theta equals 90 degrees. Okay? If x is equal to 0 and y is less than 0, then theta equals to 270 degrees. Okay, these are very, 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 very important. So I will even write it down. VI. It's very, very important. There is a way to solve it on the calculator. Again, I will start showing it after question 21, because after question 21, you should have mastered these formulas. So, screenshot them, write them down, do whatever you want with them. This is very, very, very important. Please remember them. Okay. I just summarized polar coordinates in 2 seconds. So, like, genuinely, this is a very useful formula list. Now, we need the polar coordinate pairs for -4 and -3. Okay, to start, let's find r. Let's find our magnitude. Our magnitude is going to be -4 squared plus -3 squared. So, this is going to give me 16 plus 9, which we found earlier is radical 25, which I'm just going to skip and write 5 straight away. Okay, now, theta. Okay, remember, polar coordinates are r comma theta. So, we found r. R is done. Theta. It's going to be, since x is less than 0, as you can see, it's -4 here. This is x. Theta will equal to 180 plus the inverse tangent of y over x. I did show an explanation for this in the CA video quiz. I will re-explain it. Why it's 180 plus the inverse tangent if x is negative. In a question where I actually can see the graph, because this needs a graph to accurately explain. Anyway, so now that we know this part, right? We know what the formula for theta, we've identified it. Theta is going to equal to 180 plus the inverse tangent of -3 over -4. So remember, it's y over x. So 180 plus inverse tangent -3 over -4 gives me 216.8, which will round to 217 degrees. So as a polar coordinate form, it's going to give me 5, 217 degrees. Okay, moving on. The polar coordinates of point A are 4 and 30 degrees. It's expressed in the x and y coordinates as AI plus BJ. Find A and B. Okay, so I taught you how to convert from Cartesian to polar. Now we're converting from polar to Cartesian. Okay, this one's even easier because there's only 2 formulas you need to memorize. So for x, okay, which in this case is AI, which in this case is A, obviously. It's gonna be r cosine theta, okay? But for y, it's gonna be r sine theta. Remember these two. If you're writing notes, please combine them with your with the notes on the Cartesian to polar. This is just a quick formula. Okay, now that we know these, we can apply it. So let's start with x. X is equal to r. This is r and this is theta. So r is 4 cosine 30. 4 cosine 30 will give you 4 cosine 30 on the calculator, 3.46 rounded to 3.5, and that's A done. Now B is y. So y is going to equal to r sine theta, which equals to 4 sine 30. You should know that sine 30 is 0.5, so it's going to be 4 times 0.5, which is just 2. So this is my answer, and then they told you express your answer to two significant figures, so you'll write 2.0. Moving on, question 9. The position vector of point A has a magnitude of 10 meters at a heading of west 37 degrees. So let's plot this on a graph. Okay, so on a graph, north, south, east, west. West 37 degrees south, so it's going to be something like this. Okay, 37 degrees. Okay, and the magnitude, this is A equals to 10 meters. Now, they have another vector, B. B has a magnitude of 5 meters on a bearing of 143. So bearings, as you know, start off like this. 143, so we'll start off, you know, the angle between two quadrants is 90 degrees. So it's going to be 90, 180, 270, but we don't want to go as far as 270. So it's going to be 90, and then let's say 143C. Okay, so this angle here is going to be 143 minus 90, which is 53 degrees. So this part here is 53 degrees. Okay, so they want the resultant vector. Now, the resultant vector, we're going to have to find in Cartesian notation. So we're going to have to find this vector first in Cartesian notation, vector A, and then vector B in Cartesian notation. So how do we do this? It's very easy, very simple. We're going to have to change from polar to Cartesian. So our thing is going to be 10 for A. It's going to be 10, comma. Now, here's the tricky part. It's not 37 degrees. It is, again, what did I say theta was? Theta is the angle between positive x-axis and the vector. Okay, so it's actually starting from here and ending here. So how do we find this? Again, remember the angle between two quadrants is 190 degrees. So this here is 90, this here is 180, 180, and then you have 37 degrees to go down to the vector. So what's 180 plus 37? 180 plus 37 is 217 degrees. So this is 217 degrees, right? Because I went 180 till here, stopped here, and then I know that it's 37 degrees south from here. So I know that I have to add 37 degrees just to get to that vector after the 180. So I do 180 plus 37, which is 217. So this is my answer for A. A is 10, 217 degrees. Okay, now doing this on hand, because I'm not going to do this on a calculator now. 10, so x is going to equal to 10 cosine 217 degrees. Gives me 10 cosine 217 negative 8 I. Okay, because it's negative 7.98, but you can round. And now y is going to equal to 10 sine 217 degrees, which gives me negative 6j. Okay, so it's going to be A is equal to negative 8i minus 6j. I'm leaving this here because now I'm going to erase this and work with vector B. For vector B, okay, I don't need you anymore. I don't need you anymore. I'm going to erase all of vector A actually because I don't need it anymore. Okay, B is going to be, so here it's 53 degrees, right? Why is this relevant? Remember, why did I find this angle? Because this angle, this 53 degrees, is the angle between the vector and the positive x-axis, as you can see here. So this is equal to theta, right? So my vector B is, initially, I always found it from the start, 5, 53 degrees. So now I can do x is equal to 5 cosine 53, which equals to 5 cosine 53. 3i, y is equal to 5 sine 53, which equals to 4j. Okay, so b is equal to 3i plus 4j. Okay, now I'm going to erase all of this, even the graph, because I don't need it anymore. They want the resultant, so I combine I with I and j with j. So negative 8i plus 3i, which equals to negative 5i. And they said it's expressed as the form pi plus qj, so this is equal to p. P is negative 5. Okay, now for q, I'm combining, so for qj, I'm combining my j, right? So it's going to be negative 6j plus 4j. Or sorry, 1 second, I think I did something. Here's what I did wrong. Okay, it's actually, I just realized. So, let me graph this again. This is the angle theta. This theta is equal to 53 degrees. However, the direction matters. In polar, you're going from the positive x-axis and going up. Okay, but here I started from the positive x-axis and went down. So this is negative. This is negative 53 degrees. Okay, negative 53 degrees. So, recalculating, I should get the same I, but a different j. So 5 cosine negative 53. Yeah, 3i. Now 5 sine negative 53. Negative 4j. So this is minus 4j. Okay, so now I combine I with I and j with j. So pi is equal to negative 8i plus 3i, which equals to negative 5i. Okay. Now qj is equal to negative 6j minus 4j, which gives me negative 10j. So my final answer is negative 5i minus 10j. Okay, moving on to question 10. Vector OA is shown in the diagram below. The angle that OA makes with the positive x-axis. So first, let's find what vector OA is. So we're starting off from 0, 0. And we're ending at 1, 2, 3, 4. So negative 4, 1, 2, 3. So we're ending off at negative 4, negative 3. Right? So this is A, this is O. Subtract from each other to find vector OA. Remember, it's terminal minus initial. So negative 4 minus 0. Which is negative 4, negative 3 minus 0 is negative 3. This is my vector. Okay? Now, they want the angle that OA makes with a positive x-axis. So they want all of this. Now, you know, since x is negative, x is less than 0, theta will equal to 180 plus the inverse tangent of y over x. Here I can show the derivation of this. Here I can show how this makes sense. Look, the positive x-axis is here, right? So I'm gonna go all the way here till my vector, okay? But I can split this up in two things, in two ways. I can split it up like this, okay? So I'll have this part and this part. I split it up into two parts, sorry, not two ways. So I have this part here, this angle here, whatever it is, and this angle here, whatever that is. Okay, now, if you notice, if you remember, the angle between two quadrants is 90 degrees, right? So this is 90 here, this is 90 here. This part, this whole part here, this is 180 degrees. Okay, now, this angle here, we know from the formula, is tan inverse y over x, right? This angle here, this theta. Okay, so how did we get 180 plus tan inverse y over x? It's going to be 180. Let's not call this theta. Let's call this alpha. It's actually 180 plus alpha to find the total angle, right? You can obviously find tan inverse using trigonometry. Like if I do this, if I do it like this and like this, look, I have a right triangle now. And then I have this angle and this angle. I have negative 4 here. and negative 3 here. The tangent is going to be opposite over adjacent. So it's going to be negative 3 over negative 4. That's how you find tan inverse of y over x. Okay? But let's not bore you with that detail. So alpha's here, right? Say you have angle alpha. But you're wondering, how did you get 180 plus y tan inverse y over x? Remember, I split it up into like this. I have this entire angle, split it up into 2 parts, right? This part's 180, this part's alpha. So it's going to be 180 plus alpha. And alpha is equal to tan inverse of y over x. Just so you know, so you have an understanding of how did I get this formula, which makes it more applicable in the exam. Just in case you forget it, you can easily derive it. It's basic trigonometry and angle addition, really. It's not that hard. So now that you know it, we can easily just apply the formula now without even checking anything. So 180 plus tan inverse of negative 3 over negative 4 gives me 217 degrees, which is my answer. Okay, so all of this here is 217 degrees, right? They want the bearing. Let's count. So, first of all, that means subtract 217 minus 180. I'll get 37 degrees. So alpha, this part, again, we're calling this part alpha, is 37 degrees. Okay, this part is 180. That's why I subtracted 180. I want to find alpha separately. So let me put this back on here. Okay, now this means that if I subtract 90 minus 37, I'll get this part here, this part. This part is 90 minus 37, which is 53 degrees. Okay, why am I finding this? Because they want the bearing. The bearing, it starts off from the positive y-axis and goes downwards. It goes in the clockwise direction. So they want to find the bearing of OA. So I start from the positive x-axis and stop at the vector OA. So angle between two quadrants is 90 degrees, 90, 180, and then 180 plus 53 will allow me to reach my vector, right? So 180 plus 53, 233 degrees, and that's my answer. And again, how did I get it? I split this up into 2 parts. This is 180, this is 53, I reached my vector. So, is that it? No. 2 possible ways of to describe OA using Mariner's compass. Okay, so let's say this here is 37, and this here is 53. Okay, now this is west, this is S. Now, you start off at the west. This is how you read Mariner's compass. You start off at the west, okay, and then there you will go a certain theta in another direction. That here they gave me south. So west theta south. So I'm going down. I start off at west and I go in the southern direction. So I'm going down by theta degrees towards south. I'm sure you guys already know this, and we've been tested on this twice so far. So here we know that from west to the vector is 37 degrees, and as you can see, it's going downwards towards the south. So it's gonna be west 37 degrees south. But you can write the opposite of it. You can start off at the south, right? And you I'm gonna ignore this. I opened it by accident. I'll have to let me just, there we go. The writing's all gone now. It's fine. So this part was 37. This part was 53. West 37 degrees south. Now I can start off at the south, right? And I know the angle between the southern point on the y-axis, so the negative y-axis, and the vector is 53 degrees. South is here, right? The vector is here. The difference is 53 degrees between them. So south 53 degrees, and as you can see, I'm moving towards the west, so south 53 degrees west. That's how you solve this. Question 11. The position vector of A has magnitude 5 kilometers along a heading of north 30 degrees west. Vector OA is expressed as, this is the Cartesian. Okay, so this is the north, this is the west. North, 30 degrees west. So I started off north, I'm heading 30 degrees west. Let's say like here. So this is 30 degrees. Okay, now, how do we change this? So let's say this is the magnitude of 5 kilometers. How would I change this into Cartesian notation? Okay, this is actually very easy. What I do is I convert this into polar. I convert my given into polar. Then I can convert from polar to Cartesian, right? So I know that theta, so I know that polar is expressed as r comma theta. I have r is 5, so it's going to be 5 comma theta. Okay, and I know that theta is the angle between the positive x-axis and the vector, right? So it's between this and here. Okay, now for the millionth time, what's the angle between two coordinates? It's gonna be 90 degrees. So 90 degrees here, 30 degrees here. What's 90 plus 30? 120. So it's gonna be 5 comma 120 degrees. Okay, or yeah. Now this equals to, in Cartesian notation, x as 5 cosine 120, which gives me 5 cosine 120 negative 2.5, and y as 5 sine 120, which is 4.3. Okay, so this can be rewritten as negative 2.5i plus 4.3j. There we go. So question solved. Moving on. Question 12. Drag and drop the correct terms from the box to express each using mariner's compass. Okay, so they want 60. So north, south, east, west. They want 60 degrees. 60 degrees, by the way, this is as like a bearing. They want this as like a, they should have like made it clear. But like 60 degrees, it's from here. So here's 0 degrees, right? Here's 90 degrees. Remember, I'm doing this. The angles between two axes. 180 degrees here. 270 degrees here. Right? Between this and this is 90, but from north. Sorry. From north all the way to here is going to be 270 degrees. That's what that means. So like basically from here to here is 180 degrees, from here to here is 90, from here to here is 270, and then from here to here is 360. Okay, so now they want 60 degrees. That's 60 degrees is here. This is 60 degrees. Okay, now let me evaluate my options. I have east 30 degrees north. Okay, this is very promising because if I start off east and I go 30 degrees north, I'll end up with this. I'll have a vector here 30 degrees, and that's 30 minus 30 minus 90 is 60. So I have 60 degrees here, which is why this is the correct answer. But let's evaluate it more. West 30 degrees north. West, and then I go 30 degrees in the northern direction. So like this. Okay, this is 30. As you can see, this and this are not the same vector. So this is wrong. West 60 degrees north. Anyway, you can see my vectors between the north and the east, right? So how will it be from west and go north? It won't work. East 300 degrees south. So east, and then I move 300 degrees south. So 90, sorry, 90, 180, 270, and then 300. This is wrong. Why? Like, look here. So 90, 180, 270, and then 300 is 270 plus 30 degrees. So the vector they're actually describing, okay, the vector they're actually describing is something like this. It's gonna be 30 degrees from the north, right? Because look, 90, 180, 270. 270 plus 30 gives me 300. No, my vector was 60 degrees. So this is wrong. It's the other way around. So this is why this is incorrect. Okay. East 60 degrees south, I don't even need to explain this is wrong. East 60 degrees south, my vector will be here. No, my vector was here. So 60 degrees, 30 degrees. So leaving me with this as the correct option, and I already explained why. Okay, now let's erase all of this because this is a different vector that they gave me now. 300 degrees. So 270, 300 somewhere here. 30 degrees here, 60 degrees here. Okay. East 30 degrees north. We just found it for the other vector, it can't be the same. West 30 degrees north. I start off at the west, I went up 30 degrees north, which is why I have 30 degrees here. This is correct. West 60 degrees north. West 60 degrees, that means I'd have 60 here, not 30. But I have 30 given to me. So this is wrong. East 300 degrees south, I said the vector will be here. So this is wrong. East 60 degrees south, I'll end up somewhere here. This is wrong. Leaving this as the correct answer. Sorry, I circled the wrong thing. Leaving this as my correct answer. Moving on. In Cartesian form, the position vector of point M is, okay. You already know. This is negative 3, 2. Or let's express it in general form, A, comma, B. As a vector, this is going to be AI, plus bj. But this is the basics, and I'm assuming you already know this because you should يعني. So applying this negative 3 comma 2, it's gonna be negative 3i plus 2j. Okay, question 14. Points A, B, and points A and B are these two, whatever, and vector BC is this, the same coordinate system, vector AC. They want to find vector AC. Okay, now AC. Okay, if you think about it, vector AC is vector AB plus vector BC. Now, there are multiple methods to solving this question. I showed another one in the CA quiz, which is why I'm showing this one in this quiz, okay? Because there is more than one method solving it, and it depends on your preferences, because some people prefer the other method, some people prefer this method, which is why I'm covering both, but in separate videos, because this quiz is still very long, and I'm 40 minutes in. So, we're not even halfway there with this quiz. So AC, let's find the vector AB. Vector AB is B minus A, right? So 2 minus 4, negative 2, minus 2 minus 7, minus 2 minus 7, yeah, negative 9. Okay, this is my vector AB, right? I did the addition mentally, you can see. 2 minus 4 is negative 2, minus 2 minus 7, negative 9. Plus, you can't trace it back mentally. You're starting off at point A and you're going to point B, right? So, you started off at 4 centimeters and you went to 2 centimeters. How did you do that? You went back 2, right? And then 7 centimeters as you're starting, you ended up at negative 2 centimeters. You went down 9. So, since you went back 2, it's going to be negative 2. Since you went down 9, it's going to be negative 9. That's it. It's mental math. Now, okay. Now we just add it to vector BC. So, negative 2, negative 9, plus, oh my god, why am I in Google Messages? 3, 4. Okay, so, negative 2 plus 3, 1. Negative 9 plus 4, 5. So it's going to be 1, 5. This question, by the way, as you know, it's even in the AMS quiz last 2 weeks ago. This is question's incorrect. Okay, it's incorrect. So this is the actual answer. Sorry, this is negative 5. What? I'm going in everything. It's negative 5. So here, this is the correct answer. Okay, but they put it wrong here. It's all good, no problem. Question 15, I will skip because question 15 is a repeated question from one of the other questions in the quiz. And by the way, there are multiple repeated questions in this quiz. There's like 2 or 3, maybe even 4, but I'm only skipping question 15 because it's very, very easy. And it's exactly copy-paste. It is the same exact question. I'm not sure which question it was, but if you do the quiz, I think it was question 9. Not sure, but it's the same question, copy-paste. So I'll be skipping it. Okay, question 16. The diagram below shows several vectors. Each is a small square on the graph paper is 1 meter in length. The sum of two. Okay, so we'll start off with part A. Vector equal to A. Okay, vector equal to A means that it has to have the same magnitude as A and it has to be in the same direction. As you can see, this goes 1 and then like 1 and a bit, right? And it's going in this direction. So I need a vector that's in this direction. Immediately, the only vector that exists like this is C, which is very long. It's way longer than A, so this C is wrong. Okay, and H. H looks to be the same height as A, so that means H is my answer. Now, vector opposite to H is my second part. Vector opposite to H means it's the same magnitude but in opposite directions. What's the opposite direction of like something going like this? It can be something like this. So, A is out, C is out, E is out, F is out, D is out, leaving B. Right? Look, generally, I don't even have to compare their magnitudes. Look, C is in the same direction as H. A is in the same direction as H. G, we'll leave it, but it's obviously way shorter than H, right? Look, G is this small, then H is this. So G is out. F is not even in the same direction or opposite. E is also very small compared to H, so it's out. D is even smaller and it's not even in the same direction, so D is out. It leaves B, which is why B is my answer. Okay, now vector parallel to D. Okay, so D is this. Okay, this is D. Sorry, oh my god, this is D. Okay, let me go down so I can see the questions later. Vector parallel to D is this, right? That means it's in the same direction as D. So, by the way, keep in mind, we should have learned this in math last year. If a vector A, okay, is some constant as a scalar multiple, we call it a scalar multiple of a vector V, then A and V are parallel, okay? So, if they tell you parallel lines, that doesn't mean that A and B have, say you have two vectors, or they ask you if they're parallel. Doesn't mean that they have to have the same magnitude, no. I could have a vector like this, that's going vector A, and then I have another vector V like this. They are parallel, they're never meeting, but vector V is clearly bigger, right? So, they are parallel, and this rule will always apply. If A is equal to some constant multiplied by the vector V, then vectors A and V are parallel, okay? So, here, D is this direction, so I need something in this direction too, right? This is out, 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 this is out. You can see they're not even in the same direction. I need something going straight up. What's left? Vector F. Okay, so vector parallel to D is vector F. Now, vector that's a scalar multiple. I just answered this with this. Right? A scalar multiple, it means constant, any constant times a vector. Okay? A here. Because this is a scalar, right? It's a scalar and it's getting multiplied. So it's a scalar multiple of a vector. Right? So that means that F is my scalar multiple, because as you can see, it's F is equal to this is going one up, right? 1, and then this is going 2. So this is F is equal to 2D, as you can see from the figure, right? So this matches the form A equals KV, right? Which means that not only is F parallel to D, but F is a scalar multiple of D. Okay. Moving on, the sum of two vectors A and B on this diagram is equal to a zero vector. Okay, so how do I have two vectors that add up? So let's say I have A here, and then I have this as B, right? A and B are the same in magnitude. Okay, so just so no one gets confused. Tell me one is longer than the other. No, I'm just a terrible drawer. They have the same magnitude, they're the same length. So now they're in opposite directions, right? So it's gonna be like this. See, this is my middle point here. This is A here and this is B here. These will cancel out, right? This is just gonna give me zero vector. Okay, this is the final vector. So essentially, what is a zero vector? A zero vector is just a point like this. Okay, because there is no vector to it. It's a point. You're not traveling anywhere. You're moving 0 up and 0 down, 0 left and 0 right. Doesn't matter. It's a point. Okay, and if a vector sum cancels out, okay, equals to 0, then it's a zero vector. So basically means it has to be in the opposite direction. It has to have the same magnitude. Okay, again, it has to have the same magnitude. I have two vectors A and B. Okay, the magnitudes have to be equal. The directions have to be the complete opposite. Okay, complete opposite from each other. That way, when they add up, they end up canceling out. So they want A and something else. What is going? So A is this, right? Oh, if this one opens one more time, I'm going to go insane. A is like this, right? So then the opposite of it is going to be something like this, right? Okay, what direction? What is this direction? What vector do I have on the given graph? It goes like this. Not A, or sorry, not F, not D, not E, not C, not H. That leaves me with G and B. Now, G is way smaller than A. It's very obviously seen, right? And remember, the vectors have to be opposite in direction, equal in magnitude. They have to be equal in magnitude. So the magnitude of this is probably half of this. So this is out, which leaves vector B. And you can see they're the same height and in opposite directions, which means that the vector sum of these two will cancel out and give me a zero vector. Okay, question 17. Vector V is given as V equals OA plus OB. Coordinates of V are, okay, OA plus OB. So this is O. O is 0, 0. right? That means that my vector, let's say OA, this is, let's calculate, 1, 2. So I move to 2, comma, 1, 2, comma 1. Okay, so OA is gonna equal to 2I plus J, right? Look, I started off at O, I moved 2 to the left, and then 1 up. And remember, I is east. Oh, sorry, this is negative 2I then. I is like this, and this is J. So this is J, this is I. Okay, so I went 2 in the opposite direction of I, so negative 2I. Plus I went in the same exact magnitude of J, so plus J. This is vector OA. OB. OB is equal to, let's erase all of this. OB is 1, 2, 3, 3I plus 1, 2, 2J. Okay, now, or sorry, 3J, I forgot this one. 1, 2, 3, 3J. Okay, now, V is OA plus OB, right? So I'm gonna combine OA plus OB. So adding them up, negative 2 plus 3, it's gonna be 1I, which I can just write as I. 1J plus 3J, 4J. And this is my final answer, 1I plus 4J. Okay, there's another part B. If the head of the vector, as you can see, this is a repeated topic. If the head of the vector V is placed at a point with coordinates negative 3 and 1, then the tail of such vector. Remember, the vector is equal to the head minus the tail. So the tail is going to be equal to the head minus the vector. Okay, so the tail is going to be equal to, we have the head. The head is negative 3 and 1. Okay, then minus the vector. The vector is 1 and 4. So negative 3 minus 1 is negative 4. 1 minus 4 is negative 3. So it's going to be negative 4, comma, negative 3. This is my... So, for question 18, as you can see, it's the same exact question as a question I covered literally 20 minutes ago. So I won't be repeating it because genuinely it's the same exact question. This is the same exact coordinate, 24 and 6. And this is the same exact coordinate of the vector that we found when you find AC and BA. Like this is the same question, So if you don't understand how to do this question, let me recap real quickly. So first you have AC is this, and then you have V is equal to this. They want V, okay? V is equal to, I'm only doing a quick recap because this is a repeated question. And question 15 is the same thing as question 9, I believe. It's the same exact concept, and that concept was really easy. It was the unit vector. So I didn't do it. Anyway, just as a quick recap. So here we find vector BA, right? Because we don't have vector BA. So BA is going to be B minus A. So 5 minus 3 is minus 8, sorry. 5 minus 3 is minus 8. 0 minus 4 is 0 plus 4 is 4. So this is vector BA. Okay, this is equal to this. Now, you know how you can check, you start off at vector B, then you go on to vector A. So I started off at 5, I went to negative 3. How did I do that? I subtracted 8. Ignore that voice crack. I started at 0, I went to 4. How do I do that? I added 4. So this is vector BA. Now, V is equal to 3AC times VA. 3AC is this, so 3 times 3 is 9. 4 times 3 is 12, minus 2BA, 2 times negative 8 is negative 16, 4 times 2 is 8. 9 minus 16, sorry, ignore this, this is another topic. 9 minus 16, 9 becomes 9 plus 16 because 2 negatives make a positive, 9 plus 16 is 25. 12 minus 8 is 4, so this is vector V, 25I and 4J. Now, the tail, recall that the formula of the vector is head minus tail, or terminal minus initial, same thing. So the head is going to equal to the vector plus the tail, right? So the head is equal to 25, 4 plus the tail is negative 1 and 2. So you add this to give me 25 minus 1, 24, 4 and 2, 6. This is my answer. Moving on to question 19. Question 19, parts A and B are also repeated, and you should definitely know how to do them. The resultant force, you combine I with I and J with J, and then the magnitude is the radical of the coefficient of I, so let's say it's A, and the coefficient of B, which is, let's say, coefficient of J, which let's say it's B. This is the new part of the question. What's the angle between the unit vector, the direction of F, and the positive x-axis? So, you have this. This is your thing, right here. 3I, 4J, so here. Okay, now you're gonna want to change it to polar. So you have Cartesian. Sorry. Oh my god, not this. You have Cartesian. And you want to go to polar. How do you do it again? The formulas. It's so first of all you find its magnitude, which you know it's 5. Remember, polar is written as, if this comes up one more time, it's written as r comma theta. R is the magnitude. Theta is the angle between the vector and the positive x-axis. Okay, so now you have r. R is 5. You need theta. Since x is greater than 0, because look, the resultant force is 3i plus 4j, meaning it's 3x and 4y. Okay, you can write it as that if x and y are your unit vectors, right? X is greater than 0, right? Because you're moving upwards. So this is your vector here. Let's say it started off at 0 and then it moved here. Okay, so this here would be 3, this here would be 4. So it's going to be tan inverse of 4 over 3. Okay, remember it's y over x. So tan negative 1, 4 over 3. 53.1 degrees rounds to 53 degrees. And this is your final answer. Question 20. Remember the formulas, by the way. This is also a repeated question. This first part is a repeated question. This second part here, this is new. So, this is your bullet, right? Here. This is your bullet. 9i and 3j here. So, this is 9, this is 3. Tamam? So, angle of elevation, it's going to be the tangent. So, they want this here. You can find it using trigonometry. As you can see, this is a right triangle. This here is alpha, and then you do, this is 9, this is length is 3. What's it? Opposite over adjacent, so tan inverse 3 over 9, which is equal to tan inverse 3 over 9, from 18.43, 18 degrees. As I said, you don't need to derive it from the trigonometry, you know, the original trigonometry derivation, right? Obviously, the formula is if x is greater than 0, which in this case it is, then theta is equal to the inverse tangent of y over x. Okay, question 21. These are the applications of the formulas. Now, after this question, because by this point you should have mastered how to use these formulas, I'm going to start using the calculator method, because the calculator method is much faster. So, a vector is given by x, I, y, j, where I and j are unit vectors in the x and y directions respectively. This is the first part. If x is greater than 0, then theta is arctan y over x. Arctan, by the way, arctan means the inverse tangent, or in other words, written like this. Okay, so if x is greater than 0, it's just the inverse tangent of y over x, and if x is less than 0, it's 180 plus the inverse tangent of y over x. If x is equal to 0 and y is greater than 0, it's going to equal to 90 degrees. This is theta. And then theta is equal to 270 degrees when x is greater than 0, y less than 0. Okay. Now, if x is 28 to 45, then the polar coordinates. Now, how do you do the calculator method? Okay. Let me get a calculator that is roughly this. So, on your calculator, you want to shift from Cartesian, when you have, which is x comma y, or xi plus yj. Okay, To polar. To polar means you want to switch it into the form r comma theta. Okay, so here you have x and y, which means you have I and j, right? You want this to change to polar. So what do? You press shift, then plus. It should show you pole on the screen. Now, write the x value first, so 28 in our case. Shift right bracket, so you should see a comma. Shift on the right bracket will give you a comma. And now write negative 45. Close your bracket, you will get r is equal to 53. Theta is equal to negative 58. Okay, and that's their answer. Now, you can do 360 minus 58. Gives you 302, which is the positive angle, which is what you should be doing. Here, I don't recommend putting 58. I recommend putting 302 degrees. Because in the exam, I know someone who put a negative angle, which was the correct answer, but the system didn't accept it, it rejected it. So, look, negative 58 degrees is somewhere here, right? Between the 0 and the 90. This here is negative 58, starting from the positive x-axis going upwards. But you're going negative, so you're going downwards. Now, it's the same thing as going all the way like this in the positive direction. This is going to give you a positive angle. Okay, this is going to be 90, 180, 270, 270 is at this point. Then, what's 90 minus 58? Here's 32 degrees. This angle here is 32 degrees. So it's going to be 270 plus 32, which gives me 302 degrees. And that's my answer. Question 22. Vectors u and v are given as follows. Negative 9i plus 40j. The magnitude of v equals 37 meters at... okay, so the polar coordinates is expressed again as r comma theta. We have r, we have theta. So 37 comma negative 71. Okay, now polar coordinates of u. So this is v. Let's keep this down. The polar coordinates of u, we're gonna have to change this to Cartesian. So, or sorry, we're gonna have to change this to polar. So the same exact method. So shift plus negative 9, comma, which is the right bracket, 40, close your bracket. 41, r is equal to 41. And theta is equal to 103 degrees. Done. This is for part A. This is for U. Now, V, it's given to you in polar. From polar to Cartesian, this is what you do. You can do the x is equal to r cosine theta and y equals to r sine theta, or on your calculator, you have this very useful button called rec. Like how you saw pole, there's also rec. Now, rec changes from polar to Cartesian, and pole changes from Cartesian to polar. So, to get rec, you press shift minus. Okay, now you see rec on your screen, not pole, by pressing shift minus. Write your magnitude first, 37, comma, write your angle now, negative 71. You should see x is equal to 12.04, so we're going to round to 12. And y is equal to negative 34.98, we're going to round to negative 35. And this is my x and y for vector v. Okay, question 23. A position vector opposite to r. Okay, this is a good question. Now, part A is very, very easy. In polar coordinates, this is vector r. So r is 43 or 73, sorry, comma 49. Now, position vector opposite to r. So first we're gonna have to find this in I and j. Then we're gonna switch the signs, right? Because it's gonna have the same magnitude and the opposite direction if we're switching the signs. So, shift minus to give me rec 73, comma 49. I get x to be 47.8 or around 48. Y is equal to 55, so or like this. Okay, now this is r. R is equal to 48i plus 55j. Okay, now they want the vector opposite to r. So it's gonna be negative 48i plus or minus 55j. Done, this is your answer. Now, a vector perpendicular to r and located above the x-axis Can be, okay. Now, perpendicular. When you have a vector perpendicular means you have x comma y, okay, and then it got shifted by 90 degrees. Now there's two possibilities. You can either have, sorry, I had to cut the video for a second. So where was I? Yes, after 90-degree rotation, x comma y can become y, oh my god, can become y comma negative x if it's a clockwise rotation, and, or sorry, y comma negative x and negative y comma x if it's a counterclockwise rotation. But obviously you don't need this for this question, right? You can solve using this, by the way. You can genuinely easily find it using this. And it's just two rules you know from last year in math. Because you can find the magnitude. This is one way you can do. There's two ways to do it. This is one way. Okay. However, the other way is, in my opinion, easier. Yani some people like using this method. You can find the rotation coordinates and find the magnitude. You can change it back to polar, and then it gives you theta. But my method is, okay, and the nicer method is, you can shift it either 90 degrees clockwise or 90 degrees counterclockwise, right? So if you think about it, you can either add 90 or subtract 90 degrees, right? Because you started off with 49 degrees with R, and then you said perpendicular. Perpendicular always means 90 degrees. It depends on where the vector is going. So say the vector is going like this, right? If the vector, if it got shifted clockwise, then the vector would be going like this, right? However, if it got shifted counterclockwise, that changes the completely, because the vector is now going like this. Still makes 90 degrees, but opposite directions, which is why it's important to note the plus and minus. Now, they want the angle above the x-axis. So we're gonna add 90, right? Because subtracting 90 will give me a negative angle. So that means the angle will be somewhere here. So this is my vector, let's say. My vector will be here. And it's gonna make a negative angle with the x-axis. So we need it above the x-axis, so we're gonna have it shifted somewhere like this, here. Okay? Now, theta is gonna equal to 49 plus 90 degrees for the case of the above the x-axis. So 49 plus 90 gives me 139 degrees. If you didn't understand, I will give you a quick recap. So, my initial angle, okay, my initial angle is 49 degrees, right? So I have a vector like this, okay? It is going 49 degrees from here. Tamam? Now that this is clear, I can have a vector perpendicular to it, so it makes 90 degrees. However, we don't know the direction. It could be like this, okay? It could be this as its arrow, or, okay, or it could be this as its arrow. They both make 90 degrees. They're both perpendicular to each other, but they're completely opposite directions. They're the same magnitude, but again, completely opposite directions. So you don't know which is which, right? Now, here we can find it, right? By shifting. Remember, perpendicular means you're adding or subtracting 90 degrees depending on the direction. So if it was a clockwise direction, right? If it's clockwise direction, you're shifting up towards the positive y-axis. So you're moving up, which makes it above the x-axis. So it's a plus. But you can shift it down, right? You can shift it counterclockwise, making it below the x-axis, which is when you subtract. So it can be theta, the new theta, which is perpendicular to r. It can be 49 plus or minus 90 degrees. Right? But in the case that we want it above the x-axis, like the question asks, theta is going to be 49 plus 90, which gives me 139 degrees, and that's my answer. Now, don't concern yourself with it says that r equals 1. It didn't say that it didn't say that the vector perpendicular to r has to have the same magnitude as r. Here's why. Because look, they want the vector fully above the x-axis. So this is vector r, right? Okay, now this would be my perpendicular vector, something like this. Look how small it is, and it's all above the x-axis, because if the magnitude was like 57, it would be like this, right? So it would be some above the x-axis, some below, right? So this is the actual vector. So that's why you don't concern yourself with this. You only care about the angle. The angle is what they want you to find, not the magnitude. They won't ask you to find the magnitude unless the angle is given. So don't worry about that, okay? They won't ask you to find both at the time, and then you can use the formula for polar to find r anyway. So it's much easier if they leave this blank and give you this. But I hope you know why, because again, just remember, theta, if you want it above the x-axis, our theta above the x-axis, it's just gonna be 49 plus 90. That's your answer. Okay, moving on. So, question 24. The angle OA makes with a positive x-axis is, Okay, now this was explained in the CA quiz before. So here, right? They told me in the given up here vector OE shown diagram below. So here I have 1, 2, 3, 4. Okay, so negative 4i and 1, 2, 3, negative 3j, right? Because I'm going 4 to the left and 3 down. So negative 4i minus 3j. Okay, now the angle that OA makes with the positive x-axis, as you can see, it's negative, right? So x is less than 0. So what we're gonna have to apply is 180 plus tan inverse of y over x. So 180 plus inverse tangent of negative 3 over 4. Do this, you will get, so 180 plus inverse tangent of negative 3 over 4, or negative 3 over negative 4. So this gives me 217 degrees. That's the answer to my first part. Now, the bearing. Okay, so we established that this whole thing here is 217 degrees, right? Now, as I said before twice, you can split this into two parts. This part here is 180, and this part here is 217 minus 180, which is 37 degrees. Okay, so this part here is 37 degrees, and that's what I'm concerned about here. 37 degrees, right? Because again, this part here is 180, and then add them up, they'll give you 217. That's the angle that it makes with the positive x-axis. However, the angle it makes with the negative x-axis is 37. Now, the bearing starts from the positive y-axis and goes clockwise. So, let's count. So here's 90, 180. It's 180 plus whatever this angle here is. So we can find this angle, right? What's 90 minus 37? 53. So it's gonna be 90 plus, 90, 180, and then 180 plus 53, which gives me 233 degrees, and that's the bearing of my vector. Now, two possible ways of describing this using Mariner's compass. I start off west and then I move 37 degrees south. As you can see, this is again a repeated concept. Okay, it was in the quiz before. I explained this maybe 30 minutes ago. Okay, and I can start off south and move 53 degrees west. So that's exactly what we're gonna write. West 37 degrees south and S 53 degrees west. Question 25. The angle OA makes with the positive x-axis is 120 degrees. Now, how do we know? This here is 90. Okay, again, this part is 90, and then they told you it makes an angle of 30 degrees with the positive y-axis. So from here to here is 30, right? 30 plus 90, 120. That's your answer. The bearing of OA. So this here is 30, right? Then that means this here is 60. Okay, so again, the bearing from the positive y-axis, 90, 180, 270. 270 plus 60 will give me the bearing between the bearing of the vector. 270 plus 60, 330. That's my final answer for this one. In the Mariner compass notation, direction of OA. Direction of OA, you can start off north, then move south 30 degrees, or move west 30 degrees. So it's going to be N 30 degrees west. Or you can start off west and move 60 degrees north, and that's your other answer, was 60 degrees north. Okay. Question 26. So, for question 26, we're going to apply the concept I told you before. So you start off with the angle theta, and then theta 1, let's call it, and theta 2, when it's perpendicular, for this part, by the way, for this part here. When it's perpendicular, you can do plus or minus 90. So vector OA has a length of 17 meters, so this is its magnitude r, and then this is theta in Mariner's compass. So let's graph this. So let's draw it on a bigger scale. So like this. Okay, now north, south, east, west. East 28 degrees north, so somewhere here. That's a bit too high. East 28 degrees north, here. Okay, this is east 28 degrees north. Now, they want, first of all, the Cartesian notation. So, r is 17, and theta is 28, right? Because look, again, theta is the angle between the positive x-axis and the vector. This is the positive x-axis where the east lies, and then I moved up to the vector 28 degrees as given here, east 28 north. Okay, so my angle is 28 degrees already, so I don't have to do any conversion or calculation or anything. So now, do it with me on the calculator. Shift minus to give me rec 17, 28. X is 15, so let's say 15i straight away, plus 7.98, let's say 8j. Done. 15i plus 8j. Now, from the smallest to the largest, again, now, your initial angle was 28 degrees, right? 28 degrees. This is theta 1. Now, the new theta, okay, can either be 28 plus or minus 90 degrees. So let's take the plus case. 28 plus 90 is 118, okay? Or you can have 28 minus 90, which is negative 62. Okay, so graphing these two. Let's graph negative 62 first. That means negative 62, instead of starting from the positive x-axis and going up, you're starting from the positive x-axis and going down 62 degrees. So let's say here, this is 62. Okay, now I can find this bearing very easily, right? Because from this to here is 90, right? So if this is from here, the positive y-axis to the positive x-axis is 90. Remember, the angle between axes is 90 degrees. And then from the x-axis to the vector is 62 degrees. So it's going to be 90 plus 62. 152 degrees is my first answer. Now, this is for the case of the minus 90. Let's say now you want the plus 90. So, 118 degrees. So you start off from the positive x-axis, 90, 180. But 180 is too far. So you're going to move back a bit, 90. Let's see here. Okay, now 118 minus 90. So this here is 28 degrees. Okay, now, so you start off from the positive y-axis and go clockwise. 90, 180, 270. What's 90 minus 28? 62. So here's 62 degrees, right? So 90, 180, 270. 270 plus 62 gives me 332, and that's my second bearing. Now, question 27. The bearing of OA is, so first of all, you're going to have to change this to the polar coordinate system, because when you change it to polar, you'll get theta. So, do it with me on a calculator. Shift plus gives you polar, negative 0.28, comma, where's the comma? Comma, right bracket, negative 0.96. You'll get r is equal to 1, which is obviously given to me here because they said unit vector, so I don't really care about that. Theta is equal to negative 106.26. So we're just going to round to negative 106. So now, doing this on a coordinate system, I'm moving down 106. So let's say somewhere here. Okay, so no wait, it's gonna be somewhere here because this is 90, this is 180 here, so it's gonna be less than 180 but more than 90. Now I subtract, so I want to find this part here, right? I want to find this part here. Since I know that this part plus this part is 106, so what am I gonna do? 106 minus 90. This very, very small angle here is gonna be 16 degrees. Which means that this part here is going to be 90 minus 16, which is 74 degrees. Okay, now that I have these two, it's very easy to find the bearing. I start off here, and then I'm going to go down this way. Or sorry, I'm going to start off here, and then I'm going to go this way. Now, let's do that. So, 90, 180, then 180 plus 16. 196 degrees, and that's my answer for the first part, right? Because I have 180 here, and then I'm gonna go 16 degrees to complete to this vector. Okay, now vector OB is anti-parallel to vector OA. Its magnitude is 25 meters. Okay, so anti-parallel, let me show you what anti-parallel means. Anti-parallel means they have like this, they're going in opposite directions. Okay, they are going in the opposite directions. So that means that they're gonna have exact opposite signs, right? So the negative 0.28i is gonna become 0.28i, and the negative 0.96j is gonna become plus 0.96j. However, look, they said the magnitude is 25, and you know what this is? These coordinates are for a unit vector OA. So what we're gonna do? We're gonna multiply by 25. We're gonna multiply by the magnitude to give me the actual coordinates of the vector. So 0.28 times 25, 7, 7i plus 0.96 times 25, 24g. Right? Because look, these are the coordinates of a unit vector. We don't know its magnitude. Remember, the formula is the unit vector is equal to the coefficient over the magnitude, right? So to find the coefficient of the actual vector, right, you're multiplying the magnitude by the unit vector. Because look, it's simple math. It's simple rearranging of formulas. A is equal to v unit vector multiplied by the magnitude of v. And this gives me the coordinate. This gives me the coefficient, sorry. This gives me the coefficient of I and j, respectively. So, I'm going to multiply by 25, because in this case, I have the coordinates of the unit vector, and I have the magnitude of the new vector. So, we're going to multiply the coordinates of the unit vector by the new magnitude. 7 and 24. Now, Mariner's compass, you guys already know how to do it, so let's do it very, very quickly. Let's plot this on a graph. Okay, they want OB. So 724. We're gonna actually change this to polar. So shift here, shift plus 7, comma 24 gives me 73 degrees. 73 degrees here. So it's gonna be somewhere here. Now 90 minus 73, or 90 minus 74, it's actually close to 74. 16 degrees. So this here is 16 degrees. And that's my answer. And 16 degrees east. Or sorry, 16 degrees here. Now, moving on. Remember, I'm just rushing through the mariner's compass because you guys should know it by now. Question 28. This is very, very, very easy. So, a vector is this in the form r comma theta, it's going to be 16.5. And we're going to have to sketch the graph so we can see the angle. Now, west 53 degrees north. So, west, north 53 degrees is here. So 90 minus 53, 37, so I think so, yeah, 37. So 37, now to find theta, it's going to be 90 plus 37, because remember this and this is 90 here, this and this is, this part's 90. 90 plus 37, 127 degrees. So 127 degrees is the angle, and the direction of the vector is given, so that's what they want, 127 degrees, and that's the first part. The bearing, now, the bearing, it's going to be 90, 180, 270, and then 270 plus 53, 323. Done. Because, remember, I'm 270 here, I need 53 degrees up to move to reach that vector. So that's why we add 270 plus 53. And if you don't know how we get 90, 180, 270, remember the angle between two axes is 90 degrees. So this is 90 degrees, this is 90 degrees, this is 90 degrees, 90 plus 90 plus 90, 270. Now, the Cartesian coordinates of this vector, we have it in polar form. We can do it on a calculator. Shift minus gives me rec 16.5. Shift or shift right bracket 127. Negative 9.29, which is negative 10i plus 13g. Now, moving on to the next question. Question 29, which is the last one. Vector directed at west 37 degrees north. So this is west 37 degrees north. It's obviously going to be this one, vector E, because if you think about this is way too steep to be 37 degrees, right? This is way closer to the y-axis than it is to this line, right? So I moved way more than 37 degrees. So first part is E. It's common sense. Vector with bearing 37 degrees. So I start off at the positive y-axis and I move 37 degrees from there, which is logically going to be A, right? Because B, it looks more like 60 degrees or 45 degrees. Not 37. So vector is my answer. Now vector whose direction is in the polar coordinate 37. So that means from the positive x-axis to the vector itself, it's going to be 37 degrees. So obviously it's going to look like it's going to be B, because look, this is not a very big angle, and this can be very easily inferred to be 37 degrees, right? Because you're starting off from the positive x-axis and you're moving to the vector. That's how you find the polar coordinate angle, and that's 37 degrees. And that's the end of the quiz. Good luck, guys. Good luck for the periodic. The second quiz will be out soon.